Today we're going to talk about testing rigid pipework. Rigid pipework is any metallic pipework. It could be copper, steel, stainless steel, etc. The key things I'd like you to be able to do at the end of this video would be able to explain when and why we test pipework, the different types of tests you can carry out on rigid pipework, including the prep before the test, the appropriate pressures for the test, and the length of the test. Also, I would like you to be able to explain what we would do after testing. So when do we test? We test after any new installation. We should also test after any extension or repair or modification to an existing installation. Reason being is to search for leaks, essentially to find any leaks. It's a regulatory requirement required in the water regulations to prevent expensive callbacks. We should also test after long periods of inactivity. The reason being is, again, it's a regulatory requirement. After periods of long inactivity, the system could have developed leaks, and we need to check to ensure that is not the case. So why do we test? Before I mentioned, it's a regulatory requirement. It's to comply with the water regulations. And the reason that we test, the reason that we have to test, is to find leaks and ensure that the system is structurally sound. If we do this, it should prevent costly repairs in the future. So there's two main methods of testing for rigid pipework. One set out in BSE and 806, and the other one is set out in the water regulations. There's a lot of similarities to both of them. They will both need us to carry out a visual inspection of the system before filling, check it's ready to be filled, check there's no open ends, check it's clipped appropriately, check it's in good condition. Once we've done that, we can then fill it with clean, fresh, wholesome water, known as Category 1 water in the water regulations, and would vent all air out of it prior to testing. Look at BSE and 806 first, but I would prefer for you to use the water regulations over BSE and 806 unless specified. BSE and 806 tells us that if there's a difference in temperature of more than 10 degrees C between the water coming into the system and the air temperature, then we should leave the water in the system for 30 minutes prior to testing. This is to allow for temperature stabilisation. As the water heats up or cools down, it will expand or contract, which could cause a pressure fluctuation during the test. Leaving it for 30 minutes prior to testing will help prevent that. BSE in 806, it tells us that we would pump the pressure up to 1.1 times the working pressure and then leave it on test for 10 minutes. So, for example, if the working pressure was 1 bar, you'd test it to 1.1 bar. If the working pressure was 2 bar, you'd test it to 2.2 bar, and so on and so forth. So if you find what 10% of the working pressure is, you add it to the working pressure, and that would help you find 1.1 times the working pressure. And for this test in BSE and 806, we leave it on test for only 10 minutes. There must be no drop in pressure and no visible leaks. If that's the case, then the system's passed. If it's not the case, if there's any visible leakage, even a week, we need to stop the test, find and fix, and restart the test. Water regulations tell us that we need to test it for a higher pressure and for a longer time. This is the one that is preferable to use unless otherwise specified, so you should test it to 1.5 times the working pressure, and you should leave it on test for 1 hour. Again, there should be no drop in pressure, no visible leaks. If we find any, then we'd have to stop the test, fix the leak, and restart the test. Just like with BSE and 806, if we find out, in this case, what half the working pressure is, and you add it to the working pressure, that would help us calculate 1.5 times the working pressure. So we'll use 2 bar as an example. So the working pressure is 2 bar. We know that half of 2 is 1. So therefore we would test it to 3 bar. So we take the working pressure of 2 bar, we add half the working pressure of 1 bar, and then we test it to 1.5 times the working pressure. Do another example. If the working pressure was 5 bar, we test it to 7.5 bar. Half of 5, 2.5, add that to the 5, gives us 7.5. So after the test, we need to make sure that we record the results. So whatever appropriate paperwork is, we'd record the results on that. Then we'd flush the system, always flush the system, particularly in new installs or alterations, because as we carry out the install or alteration, we could have introduced some dirt or debris into the system, so we need to make sure we flush that through. And we do that using wholesome water in almost all circumstances. Then we'd commission the system, check the system works the way that we want it to work, pressure, flow, and all the appliances work the way they should. And then finally we'd hand over to the customer, so that's any paperwork that's from anything that you've installed would be handed over to the customer, and explain how the system works to them. If you site work, then in this case you'd give it over to the site manager. So now you should all be able to explain when and why we test, the different types of tests, BSE and 806 and the water regulations tests, including prep, pressures and length, and what we do after testing. Hope this helps.